Alrighty, guys, ready? Take a look up here. Students, there are 3 versions of these equations that I will take. You just got to think of it logically. The first version, a sector area is simply a fraction of circle area. I will take that. Okay? What is an arc length? It is a fraction of circumference. I'm just going to use a capital C there, circumference, period. That I will take. The official equation is sector area here equals theta over 360. That's your fraction of area, which is pi r squared. Here, arc length, so I'm just going to write the word length here, is again theta over 360. That's your fraction times d pi. Half point each. I'll take either the word version, which is in the black, or the gray version, which is the actual equation. Now, guys, let me just explain something to you. Why do I want you to memorize equations? And this is a kind of an important question, because when you guys have the internet at your hand, especially when you have a phone that can talk to you, some of you, I've had students actually say this, why do I need to memorize anything? I just ask my phone. Let me ask you this. How many of you have been talking and a friend interrupted you right in the middle of a sentence and then you forgot what you were talking about? Raise your hand. Has that ever happened to you? No, you don't have intrusive friends, or you have perfect memory. Okay, listen, my point is this. Most of you raised your hands when you said if you got interrupted in the middle of a sentence, you kind of get disoriented and you can lose your train of thought. Guess what, guys? You do that to yourself all the time. You get in a train of thought, and then because you have to stop and look up an equation, or you have to stop and grab your calculator for 6 times 8, or you have to stop and grab your calculator to try to reduce 20 over 10, every single time you stop and redirect your brain to use technology, it's not that technology is bad, but you are literally interrupting the neurons that are talking to each other, and you're slowing yourself down. That's why I force you to memorize, or try to, so that when you tell yourself, how do I find area of a circle? Oh, it's a fraction of an area, and you just keep going. That is a minimal, that you're using your own brain cells. You're not interrupting your own self-talk. If you have to grab your phone and talk to Siri, you've interrupted your train of thought and you get lost. And the more difficult math problems are, the more significant that interruption is going to cost you. So you think it's busy work for me to force you to memorize stuff? It's not. I want you to be able to think efficiently. Sorry, I don't want to give you guys a soapbox lecture, but I've had too many students ask me why I need to memorize stuff. Okay. Oh, Miss Way, I don't have a calculator. It is so hard. I didn't hear that in this class. I heard that last class. It almost killed me here. So it's pi r squared, okay? And thank you for not whining. I appreciate it. Goodbye, zeros. 12 goes into 36 how many times? 3 times. So it's 1/3 pi 16. Guess what? I will take that centimeters squared. I will take that as an answer. Now, here's 2 other versions of the answer that I will take. My preferred version is 16 over 3 pi centimeters squared. That's my preferred version. Okay? Or some of you went 3 goes into 16 5 times, 1 left over, and you did 5 1/3 pi centimeters squared. Or I'll even take a 4th version. Some of you know 1/3 is 0.33, 5.33 pi centimeters squared. Okay, yes, sir. You used a calculator. No, you didn't. What's the question, sir? I'm sorry.
You do 120 over 360 pi r squared over 1 across.
No, there's no equal sign there.
Okay.
Yeah, it's fraction. It's right here. It's fraction of. That's not an is sign. That's a multiply. 3 of 5 is 3 times 5. Okay, so what's worth points? Some sort of work, half a point. 1.5 points for the correct answer. Okay. Annette, if you watch the video, this was really easy. First, you start with your base. Basically, you unfold it. So here's your base. Then you see that you have 1, 2, and 3 triangles. 1, 2, 3 triangles. That's your net right there. 2 points. Let me tell you what's worth half credit. Some students believe that all pyramids are square-based and they drew this. That's wrong. But I will allow you to get a half a point because at least you figured out it's a pyramid. But it's not a square-based pyramid. It's a triangle-based pyramid. Okay? Score out of 5, guys. Clarification questions? Nope. Score out of 5? 5 out of 5s. Pop in the back black tray. Non-5 out of 5. Start correcting.
You make it stronger.
I got analysis everywhere, apparently. Okay, all right. Alrighty, guys, you have 3 minutes to correct. 3 minutes to correct. Hold up 4 fingers. Hold up 4 fingers. I need your attention, guys.
4 fingers, Brandon.
Stay right on task. You're not paying attention. That's why you're not doing what you're supposed to be doing. Hold up 4 fingers.
Well, they're saying quiet coyote.
Yeah, that too. Whatever. Okay, guess what? That's how many lessons of new material we have in this class.
Only 4?
Including today. Yes, only 4. It is really, we are wrapping up. Now, really important. I need to turn this up. Listen carefully, guys. The next 3 class periods, especially, you have to do the video notes. The class, what we're studying is solids. Solids is anything with 3D. There's lots of hands-on stuff we could do if you come to class ready to learn. But if you don't do the preview notes, it'll feel like we're wading through mud. So I beg you, I will warn you, every single night you don't do the preview notes, I will be emailing your parents. Okay? Because you've got to stay on task with this, okay? Let me start with something simple. Ready? See this? Do not fold it physically. What I want you to do is, this is a net. Last night's videos, you had to draw a net. I want you to mentally fold this. Do not physically fold it. I want you to mentally fold this and draw what solid this would make. Mentally. Go. Draw.
Wait, this way.
Yes. What?
Drop the hammer.
Okay, ready? Your diagram should look something like this. Look, right? Okay. Now, I'm going to show you a quick little video. We're going to be talking about Khufu's pyramid. I'd like you to just watch it because I'm going to ask you several questions about the pyramid, okay? It's something called orthogonal drawings. What on?
Close we've been able to get to the wildlife has just been.
More ads. Sorry, I got. Okay. All right. So we're going to do something called orthogonal drawings. Those of you who are in art are actually going to be pretty good at this. You need to visualize. So imagine if you were standing directly in front of Khufu's pyramids, one of the faces, about 300 feet away. I'd like you to draw exactly what you would see right there. Go. I'm only going to give you about 15 seconds, guys. If you're standing, okay, like here, you're standing facing a face, not a corner, a face, directly about 300 feet away, bottom level. What would you see? I'd just like you to draw it. I'll give you my version in just a second. Okay, it should only take you about 20 seconds, guys. Focus. Stay on task. Ready? Take a look up here. How many have a triangle?
I do. I got one.
Okay, now, here's the second one. Right here is, imagine you're in a hot air balloon floating right over the top of the apex. That's the top of the pyramid looking straight down. I'd like you to draw in 2 dimensions. What would you see? Go. In 2 dimensions, what would you see? These are called orthogonal drawings. 2D drawings of 3D images. Some of you, this is going to be easier than others. Has a lot to do with the way your brain's wired. Okay, you guys ready? Got something? Okay, look there. You would see the edges. How many of you got that? Kind of a cross thing. Good. Now, for those of you in art, you know how to do this. Now, I think, Tyler, you were asking me, am I looking straight on or at the corner? Because it makes a difference here. Here, imagine you're standing about 300 feet away, facing a corner. This is now called a perspective, T-I-V-E, view. Perspective view. What's that going to look like? Draw. You're standing at the pyramid's corner, looking straight on. You got it?
The first one,
Orthogonal drawing. Yes, good call. Orthogonal. Next time you see a blueprint, you can say, oh, there's an orthogonal drawing. You'll like wow everybody around you. Orthogonal. Orthogonal is a 2D, sorry about that, 2D picture of a 3D image. Orthogonal drawings are 2D pictures of a 3D image. That's orthogonal. Okay? All right, someone in your team, take that plate, and I'd like you to hold it up at eye level, please. If you're right-handed, hold it with your left hand flat. No, if you're left-handed, you hold it with your right hand flat. Okay, hold it right in the middle of the team. Right in the middle of the team. Now, right in the middle of the team. Now, as a team, what I'd like you to do is you're going to draw 3 orthogonal drawings. 4, excuse me. Listen, pay attention. You want, if you are looking at the left side, you're going to start drawing back here. Not everyone's going to start drawing the same thing. I want you to draw, if you were eyeballing it flat on, looking at this image as a flat surface, I want you to draw all 4 views. I have the views labeled. Okay, I want everyone to do all 4 views. All 4 views. When you're done drawing, call me over so that you can I can check it. Who did I grab? Okay. So you gotta draw all 4 views. Okay, and they're labeled, guys. You're drawing that. You have to draw all 4 views.
No, I'm really screwing things these days.
It's 2D, it's flat. Okay, guys, you're not making a 3D image, you're doing a 2D image here. So you look at what that looks like. You're not doing a 3D image, you're doing a 2D image. When you're done with all 4, call me over, I want to check it.
Done.
All 4?
Yeah.
We're done.
You got it. Good, good. Sure, give that. You do these 2.
5 miles an hour.
Yeah,
I want that. I need that.
You got it. Good job. Take a shot.
I'm done.
40 miles a car, laying on the road.
Call me over when the whole team is done.
Done this way, we're all done.
You're looking at it. We just have some words, but
Yeah, it is. Flip the page, Mr. Fields. I'll show you where to go from here.
Oh, I did.
You are correct. Yes. You're good. I just haven't done it.
You're not correct.
There, now you're. Do these 2. Go.
Well, we're done.
Zach, how you doing?
Yeah.
You are. Good. Take a shot right there. Good. Take a shot of those 2. Finish.
This one right there.
That one. Good call. Take a shot right there. Oh, well then you're ahead of the game. Alrighty. Mr. Proctor, lights please. Alrighty guys, I'm going to do one more example, but there's 2 terms before I just let you go completely on your own. Take a look up here. Please get to this portion of your notes. Find the paper cut, please. And get out a calculator. Everybody needs to get out a calculator. Yes, you may have your phone out as long as it's flat where I can see it. Brandon, can you put the backpack on the ground, please? Thank you, sir. You guys, you need to get a calculator. You guys, get out a calculator. Ready? Okay, in the next 3 minutes, I'd like you to write the word here, lateral area. And write the word surface area. There's two kinds of areas we have to be able to handle. This was briefly in the notes last night. When you unfold and make a net, generally what you're doing is finding surface area, but you're going to see this term lateral. Lateral means sideways. When you make a lateral pass in football, you're passing usually either backwards or towards the sidelines, the sides, okay? Also, go like this. You're now grabbing a lat bar. Those of you guys, if you pull down, you do 100 of these, what starts burning? Your lats, which if you draw your thumbs up and down your sides, that's your latissimus dorsi. It's the same root word. Lateral means side. I do all that to help you remember. Lateral means the area of the side. So if I do this, draw little arrows like this. If I just want the paper cone, that is lateral area without a base. Now over here, I'd like you to trace what would the lateral area be. Trace it. Okay. Do you see that surface area is the lateral area plus the base, area of the base. Notice I use a capital B there. There's a reason there. So surface area includes the lateral area plus, in this case, the base. Lateral area is part of surface area. Does that make sense? Lateral area is part of surface area. We're going to do one problem together, and then you guys are on your own the rest of the period. And then you be well inside for a sign-up. Ready? Here is Khufu's pyramid. These are the actual dimensions, and the units here are all in feet. So just put a FT there to remind yourself. Okay. I've given you a partial net. I want you to pull all the dimensions here over here, please. All the dimensions from here on the left, pull them over and make a net. Go. Ask yourself what happens to that when you unfold it.
You can't
440 is the whole length. Guys, 440 is the whole side, guys. 440 is the whole edge length here. Let me color code it for you. 440 is that whole side. Pull over your numbers, guys. Pull over your numbers. Pull over your numbers. I'm going to give you about a minute to pull over those dimensions. Tina, pull over the numbers. Pull over the numbers. No, it isn't hard. Stop whining, just do it. You can manage. If you think this is hard, wait till the rest of the lesson. You're right. Oh, golly gee willikers. I was watching a program about Kennedy this past weekend about getting to the moon, and it was 1961. The Russians just put a cosmonaut before us in technology-wise, and he made the statement that we want to get to before the end of the decade. He says, we're not going to do it because it's easy. We're going to do it because it's hard. And without the space program, about 80% of the technology that you guys currently use would not exist. Computers would not exist without the space program that Kennedy started. And the whole reason why it started is because it was hard to do. So, sorry to throw down the gauntlet, guys, but you guys don't know what hard looks like. Focus. Okay? All right, so Are you guys missing a number somewhere? Is something bothering you right now? How many of you have a number and you're not quite sure to know what to do with it?
280.
What number are you kind of stuck on?
3, 5.
Okay, guess what? The 280 doesn't pull over. Okay, the 280 does not pull over. The reason why, 280 is what's called the internal height. The internal height. You do not use the internal height for area. When you unfold this into a flat surface, the internal height disappears. Okay, so these are all the units. Now, if we want the lateral area, I'd like you to stripe. Imagine the pyramid. Stripe all of the area of the pyramid that you would see above the sand. Go, stripe it. Stripe this would be the lateral area, the area around the sides. Okay, here's the pyramid. See the pyramid?
Yeah.
What would constitute, in that net, what would constitute the area above the sand? No, not everything. Okay, do you see that it's the triangles, guys? Okay, that's called the lateral area. I want you to calculate the lateral area. I'm going to draw a little arrow here. That's the area above the sand. You guys calculate the lateral area. Go. I'll give you about 1 minute as a team. Go. Talk to each other. Help each other.
Move the decimal. Move the decimal. How'd that work out for you?
Alrighty, guys. How do you find area? Yeah, what's the equation for area?
Never with you.
Area of a rectangle with 440 and a triangle.
One.
All
over 2.
Write it down. Good.
All over 2. Yes. Yes, Zach is facing. Wow. Get to go the next month for her hating
Triangle, 1/2 six height. Good. That's
Got
only
the big
1/2.
calculator out.
Which number, Jeff?
See this? I got the big calculator out. I whipped out the big calculator. I got 313.
Good. Find the circle there. Good. Where'd that number come from? How many triangles do you have, Tyler?
440.
How many triangles? Yes, times that by 4.
So you got 78,320.
Okay, no, times 4. Yes. Okay, students, take a look up here. For those of you who are not quite done, you do base times height over 2, and then there's 4 of them. So we're going to go 356 times 440 equals 2 goes into 4 twice. We times by 2, and you get 313, 280. Comma, 280 feet squared. Now, if I want the total surface area, including the base, I add the lateral area, 313.
Right, 356 is the base, right?
No, it is not. 0 plus this, which is a square. So to find its area, it's simply 440 squared. Do you see that? It's 440 squared. Because it's 440 times 440. Okay? All right, you figure that out. All righty, guys. You see that? Okay, that's how you find surface area and lateral area. Before we start the rapid fire, you guys need a break. Stand up, take a minute break, stretch. Tell someone about your adventure.
Did you get proper What I do? Okay. Right on, Robin. So Friday I went running out this way. What Friday came home?
Hey.
Kyle dropped the hammer. You doing, Kyle? You doing? Saturday.
Yes, sir. I am all out. I apologize.
Right.
Okay, guys, ready? So you're going to become masters.
I'm a master.
Okay, step number 1, I'd like you to unfold and draw a net. Go.
Unfolded.
Unfold and draw a net. Then I need you to, no, that's not unfolded. It's a solid. I need you to unfold it and draw a net.
You know what? Why don't you just draw a liquid?
Draw a net. Okay, guys, I'm going to color code. Colors really help here. Now watch very closely. How many rectangles do you see, Zach, in this problem?
2.
Wait, this one?
3.
How many rectangles?
1.
No.
2.
3.
It says 3.
That's a
Be
square,
careful.
Miss Wade.
Is this one?
No, it's not a square. Okay, watch. We have 1 here at the bottom.
Right?
Do you see it? Okay, there's the 1. All right, and then the units here are going to be 8 times 5. You okay with the bottom?
Oh, yeah.
Okay, then we have this here. So I'm going to pull it here. We're folding it out. What's the dimensions there?
6.
6 times
5.
Butters. 5.
5. Good. Okay. Now we have this one in the front. Do you see the top one here?
Yes. 5
And that's
times,
kind of long.
5 times.
Okay, so we have 5 here. Do you have that? Right now, do you have it? We're going to call it X. You okay? And then here, we're going to add our little wings. Right here. Do you see the wings?
5 times 10.
Did you do that in your head?
Yes.
Good job. Yes. Okay. Now, ask yourself this. Luis, let's pull this out. Do we have a 6? We have an 8. We have a right angle. There's X. How do we solve for X? Got 2 sides of a right triangle. No? What is it?
Squared plus B squared equals C squared.
Yes. So 6 squared plus 8 squared equals unknown squared. 36, 64 equals X squared. Yes? Actual answers.
100, Miss Wade.
Okay. Is what?
100.
And then square root?
10.
10. So this right here is 10. You guys catch that? Okay. Now, you have to find the area of all of these. So this is 5 times 10. This is 8 times 5. Kyle, follow with us, please. This is 6 times 5. And then how do you find a right triangle?
A squared plus B squared.
No, we got it. Area. No, area of a right triangle.
Base times height.
Over.
2.
That's right. Base times height. 6 times 8. We're just the man over here.
You know
Over
these
2.
are on strings or neutral?
Huh?
These are on strings or neutral?
They are. Really cool. I have it on because if this goes too high, I can't reach the stupid thing.
How do you get to the house?
And this was given to me by a student years ago, and I wanted to keep it in my classroom. Alrighty, guys, go show your team how to pull that apart, okay?
Okay.
Okay, good job.
Are these squares the same? Like, are they green?
A couple of them are.
So they're not
One of them
all.
off. No. No. Is that bothering you?
That one. Yes.
Okay. Students, if you're on problem, what is that, 3 or 4? It's not. If you're on problem 4 and you're bothered, come on, join the party. Nina, come rep your team for this problem. You're 3. Go get Nina. Okay. And Mr. Courtney, you're rep for your team for this problem. Come join the party.
I like sitting here because I don't have to move up.
Yeah, right?
Okay, go get a calculator, guys. Yes, Caitlin.
You like sewing? You like sewing?
What is the shape?
You guys get a calculator? You got a calculator, Mr. Courtney?
Yes, I do.
Fabulous, fabulous. Alrighty. Tell me, Mr. Courtney, how many rectangles do you see there?
Rectangle. I see two.
Okay, let's try to count them, and we're gonna fold them out.
Four.
Good.
I forgot the top and the bottom.
Yeah. Okay, so we have this, right? Now I'm gonna color code it because it's a lot. Yes, sir. What's up?
No, it's actually a rectangle.
Technically, it is a square. Luis is correct. Technically, it is a square.
Lion.
Hey, it's 8 by 8, guys, right? Okay. Now, let's take a look here, guys. What's the dimensions of that rectangle? 6 by 8. So we're going to come here. It's a little bit more squat. This is 6 by 8. Right?
Sure, color.
All right. Yeah, color coding really does help. Let's take a look up here. What's the dimensions of this creature?
6
The purple.
by 8.
No.
6.
No. This here is 8 still, right? And what's this edge? 6. So it's 6 by 8 again. Okay. Is there another rectangle? Yes, what's up there? Do you see another rectangle there, guys?
Yes.
Where?
Right there on the other.
That. They're good. Let's draw it.
It's 6 by 8 too.
Where?
No.
Okay.
No. Whoa. Stop.
Okay. Guys, that's 8. Careful. What's that edge?
We don't know. It's a trapezoid. So we have to do the
Yeah.
trapezoid equation.
We're close. We're close. Do you see, guys? Watch, very important. Luis, do you see that blue edge there? Do you see that blue edge right there? Do you see this blue edge? Guys, do you see blue edge? Acknowledge. Yes? Okay. You do not have that blue edge. Do you see that? We're going to call it X.
Is there a Pythagorean theorem?
You're smelling the Pythagorean. Well, it's close. Guess what? Put your pencil right at that yellow dot. Put a pencil on the original diagram. Put a pencil right at the yellow dot. Zach, are you done with the problem I assigned you? Continue. Okay, Zach, I don't want to have
My homie. Why am I so excited?
Nico's going to come back and teach you that. Okay, what can you do from that dot so that you end up with a right triangle? What can you do there? Where could I draw, Nina, and make a right triangle? From that yellow dot, where can I make a right triangle?
Diagonal. Oh, sorry, you're talking.
Yes, that's okay. Yeah, okay. Behold, a right triangle. Okay, let me pull this right triangle out for you guys. Okay, what's this right here? What's that height there? No. What's this length here? 6. Got a 6. Okay, great. What's this guy right here? No, that's X. Our X is, nope, you're guessing. Magic fingers. Go like this. Go like this. Okay, ready? Okay, watch. Luis, fingers here. On your paper. On your paper. That's 6. Ready, Luis? Okay, go down here. Bracket here.
But that was 6.3.
Ready? This is 6.
Right
This is
now.
8. What's this puppy? 2. Luis, do you see? Do you see why it's 2? Yes, it is. Luis, it's very important. Do you understand why that is 2? Because if you don't, yes. Subtract what from what? Yes, 6 from 8. Okay, now this is 2. How do we solve for X? Yes. Something like that. A square root. Okay, now you're not done because you still have a couple trapezoids that you have to take care of here. Because this is 8. So this comes up like this. That's that edge length. This is 6. Your height is 6. You still have to find the area of your trapezoids.
Area of the trapezoid is 42.
Probably, yes. It's going to be 6 plus 8 over 2 times 6, something like that. Okay?
Is our X 8.5?
X should be 6.3. You know what? You missed it. It's right here. This, when you drop it straight down.
12. 12 plus 4 is
what? Get a right triangle. That's 2, buddy. That's 2, Alec. Make sense?
Yeah.
Okay. Mr. Courtney, take it. What, sir? What are we guessing at?
16. What's 16 square root?
What are we trying to do, Mr. Courtney?
That is a 6.3 right there.
All right. You do your own math for the rest. Go. Students, if you're stuck on 4, raise your hand. I'm going to come help you. Stuck on 4.